Hello. This is data science with generative AI. This is the video 3. And in this video, I'm going to speak about ChatGPT as an interactive tutor for enhancing data analysis. So the question is, how can someone without being a machine learning expert use ChatGPT to help perform data science? This is the issue. And we start with the types of prompts that we can use. Depending of the type of prompt, we can obtain a good answer or bad answer. So this is belongs to a big field now called prompt engineering. So what is prompt engineering? Is or refers to the process of designing and optimizing prompts to guide artificial intelligence models. Okay, so we can typify these prompts in many ways. This is the classification that I'm going to use in this presentation. Four types: text-based, image-based, code-based, and file-based. And of course, there are multiple ways and techniques to formulate questions. And the question, so what is the type of prompt which is more appropriate for a determined field? It depends of the field, of course. So I'm going to provide you here one example that I published with Damir Vranchik, evaluation of GPTs for control engineering education. So this is a topic. This is also data science, but for a specific topic, which is control engineering, but is good for introducing for data science. And beginning with some examples of prompts. The text base can be simple questions and answers, of course, and you can ask ChatGPT to explain and resume text. We can also ask it, and sure is very interesting, to translate text to a given certain language, and to revise and improve the text quality, and to extract keywords, the most important keywords from my text, and so on. So this is not hard to see. There are hundreds of ways of that we can ask things to ChatGPT with text. And in this example, I'm going to use a personalized GPT that have done with ChatGPT called PID Tuning Advisor. So this was to provide the rules and to tune and to help in control. So, but this is based in ChatGPT, so we probably can get similar answers with just this ChatGPT. And the first question that I provided with text-based is this: I want to implement a PID controller in a digital domain. Can you provide a program in MATLAB, which is to code and simulate a step response for a first order plus time delay model using a kind of algorithm? So this is a the prompt here is very specifies a lot of things already. The program, the MATLAB, the source code, and the algorithm and everything. So he begins to explain what is a first order plus time delay model here, and which are the parameters for the model here, and then the law for implementing the PID controller in absolute with absolute algorithm. And then it says, okay, here is the MATLAB code that you can use, which is this one. Okay, so if I pick up this code and test it, that's what I done. We can see if it is working or not. So, but then he says, okay, this is very important in the end. He says something like, okay, he uses some gains, but depending of specifics of your application, you might need to refine the PID tuning and model parameters. Okay, this is going to be obvious here because the response is really bad, but it works. It worked in MATLAB at first, so without any modification. And also, I can I ask him to replicate or to try to provide the answer. So because he doesn't have a MATLAB interpreter, he has constructed Python program to replicate it. So you can see that is the same response, but it was done with a kind of Python script. And so another example using an image, for instance, providing this response of a system. I can ask, okay, what kind of information can you provide based on this open loop step response? And he can say what are the most important transit response characteristics that are used in control. And also, he could say, okay, based on this response, which is a particular thing, which is this distance, this value between this point, this peak, and this point here that we call the first overshoot, we can see that is nearly 60%, and he could evaluate and determine that this value it was 60%. Okay, so this is interesting. So we can put some images and ask things about images. There's another example here about the ladder logic diagram, which is used in automation for programming PLCs, and also we could explain steps by step which are the main things. Okay, this is also interesting and more related with data science. Okay, can you explain the following diagram? This is a confusion matrix that we are going to see in the next video. And okay, you could say, okay, what it is, and it says, okay, this matrix is useful to see, for seeing not just how many predictions are right or wrong, but also uh, the type of errors made. Okay, it says, okay, that these are the most correct predictions, and these ones are not. So he could identify straight away that what type of graph this was and provide some explanation. So with these examples, I am going to conclude this video. Okay, so I still have another one, this file base. I'm not going to speak about the code base. The file base is really interesting because in this case, in this example, I provide some data in the kind of CSV spreadsheet data file. And okay, I told you what it was, an open loop response of a system. And I asked if you could plot the response and saying that the first column was the time, the second system input, and the third system output. And okay, here it is the response. That's data that you could find from that file. And then, okay, sometimes he got some errors, so it was not for the first attempt. But then I asked him to, okay, if you could estimate from this data the parameters for a model. And he could. I specify the type of model, and he could do it providing, as you can see here, three values for this in this case for this gain, this time, dead time, and time constant. So these are the values, and I could say, so I want to see what is the error between the model that you estimated and the data, and to see, and this is okay, you can see here, these are the real data response. This is the model simulation. So you can see here the error. So I could say, okay, so it is also interesting to see that you could manage to do this. And I'll say, I ask, okay, now I want you to optimize a model, minimizing the error between the model and the data, and provide a more the fitted response. And you can see in the red one here, this one is an optimized simulated. So we optimized, you run a kind of optimization tool to minimize the error between the model and the process. And it worked. So this is quite impressive. So it can be used for another applications as well. So that's all for now. See you in the next video. Thank you for watching.